Yes friends, we are going to discuss today quicksort technique. Okay, so again on the divide and conquer strategy, as we have discussed bandit search, we have discussed merge sort technique, we are having quicksort as well. Like merge sort, this is again another sorting technique. Name itself is a quick, right? It means what? We are going to sort the element in lesser amount of time, right? Then we are going to discuss based on that examples, algorithms or programs, time complexity analysis. In similar fashions, we are going to discuss the concept. But what is the difference compared to the merge sort and quicksort is? Merge sort, we have divided the array's element based on the mid positions, while in quicksort, we are going to divide the array element, divide the array element based on pivot. This is also called key element. Pivot or pivot elements or key elements. Okay. Now what is a pivot element? Try to understand it. Say, as for example, if you have a values called 10, 5, 15, 3, say we have a 20, 17, right, so on, right. Based on the example, based on the concept, right, say here it is, as for example, it is 8, okay. Once you are going to use pivot element, pivot position is an element where, say this is the pivot positions, then right side all the elements will be greater than pivot element. Left side all the elements will be lesser than pivot element. What is the point? This side, if suppose it is a array index, right, these are pivot positions. So these elements, say it is a 10, then this side will have say 8, 5, 9, 2, 3. This side say we have a 17, 15, 12, 20, 18. So this is the pivot element. Pivot element does the dividing the arrays element such a way that left side of the pivot element is lesser than the pivot element, right side of the arrays element will be greater than the pivot element. So in this case, all the elements this side is greater than 10, all the elements this side is lesser than 10. Similarly, once we are going to perform the task for this example, then say we are going to swap first. No, I will tell you how exactly it is, right? So 3 will come here, 10 will go there, and hence we can say that these elements are lesser than pivot element, these elements are greater than the pivot element. So basically you keep it to your mind that in quicksort technique, we are going to divide the array based on the pivot element, and that pivot element divides elements such a way that left side all the elements will be lesser than pivot element, right side all the elements will be greater than the pivot element. That is what the basic requirement is. So that is the first difference. Merge sort, we are dividing the array based on the mid positions, while in quicksort we are dividing the array based on the pivot element or key element. Okay, so let us see that how exactly we are going to perform the task and what will be the time complexity in this quicksort technique. Let us discuss one example and thereafter we will understand how to write the programs and all. Say we are having random input 10, 3, 2, 8, 12, 14, 4, 9, 7. Alright. So we have these elements. If you are writing this array index, how it will go? How it will go? Say here it is 0, 1, 2, 3, 4, 5, 6, 7, 8. So number of element is 9. right? First element, very first element you are going to consider as a pivot element. Pivot element, very first element. Next element, we are taking I as an index. Pivot is nothing but we are talking about this element. Okay. So, value of pivot is in this case is 10, while I is 1 and j will be the last index. So, in this case, I is initial value is 1 and j initial value is, our index is 8, right? Last element. Now, what is logic? Logic is if A of I is lesser than pivot element than I plus plus. So, in this place, since it is repetitions, never use if. If can be used for only one time executions. If you wanted to repeat this, we have to go with while statements. Okay. Similarly, there is another case, I comparison with pivot element, then there will be j comparisons if A of j is greater than pivot element. If A of j is greater than pivot element, then j minus minus, j index will decrease. Here, if A of I is less than equal to p pivot element, I will increase. J is, if A of j is greater than pivot element, in that case, j will decrease. Is it clear now? Okay. So let us see that. Is A of I is lesser than pivot element? Is 3 is lesser than 10? Yes. So I increases. Is 2 is lesser than 10? Look here. A of I lesser than equal to P. 2 is lesser than 10? Yes. So I increases. 8 is lesser than 10? Yes. I increases. 12 is lesser than 10? No. 12 is not lesser than 10. So hence we stop this. Then go to the next iterations. What is that? Next part will go. While A of j is greater than P. A of j is greater than P. Is 7 is greater than 10? No. Is 7 is greater than 10? No. So j is stopped here only. J is stopped there only. Now, remember that there is a logic. If position of I is less than j, position of I is less than j. In that case, we are going to swap A of I with A of j. A of I 7 and 12, we are going to swap it. So, in that case, let us see. We are having 10, 3, 2, 8. 12 and 7 got swapped. 7, 14, 4, 9, 12. Still j is here and I is here. Again we will check that. Is A of I is lesser than P? Yes, I increases. Is 7 is lesser than 10? Yes, I increases. Is 14 is lesser than 10? No. Stop it. Is a j? Is 12 is greater than 10? Yes. J decreases. Is 9 is greater than 10? No. Stop. Again, I pointer is lesser than j pointer. In that case, this and this will swap. So, we will be having 10, 3, 2, 8, 7, 9, 4, 14, 12. Now, j is here, I is here. Done? 9 is lesser than 10? Yes. 4 is lesser than 10? Yes. 14 is lesser than 10? No. Stop it. Yes? No. If first part is done, I part is done, 14 is not lesser than 10, stop it. Now go and compare with the j. Is A of j 14 is greater than 10? Yes. J decreases. J came to this direction. So j will go in right to left, I will go in left to right. Is 4 is greater than 10? No. Stop. 4 is not greater than 10. Right? Stop. So j is also stopped, I is also stopped. But now we can check the condition. Is I, what is the value of I position is? 6. What is the value of j position is? 0, 1, 2, 3, 4, 5, 6, 7, 8. This is the array index. So I position is 7, J position is 6. Is 7 is less than 6? No. In that case, it will go in else part. What is that? In that case, if I is not less than J, then swap between A of J and pivot element. A of J and pivot element. So A of J is here, pivot element is here. We need to do the swapping between A of J with pivot element. In that case, what will get it? Here will 4, 3, 2, 8, 7, 9, and here is 10, 14, 12. What I said you friend earlier is that pivot is a position which divides the array into two parts such a way that left side of the pivot element is lesser than right side of the pivot element is greater than the pivot element. So same things we are experiencing it here is after first iterations, after swapping, we got 10. These are the pivot elements. Position is 6. Before this, all the elements are lesser than 10. So this array is divided based on the pivot element. Right side of the pivot element is greater than 10. It means 10 is already there at the sorted positions. So we are not going to again consider for the iterations. Just we leave that positions as it is. So in that case, what is that? 0, 1, 2, 3, 4, 5 is index. This side 6 is gone. These are 6 positions. This is 7 and 8. Look, left side of the arrays is low to these positions j minus 1. Right side is j plus 1. 6 plus 1 is 7. So we are dividing the arrays based on pivot element j minus 1, j plus 1. Okay, alright. So next again we have a two unsorted array, left unsorted array, right unsorted array. Again you are going to perform the same task. So let us see that in that case, this is the pivot element, next element is going to be the I, and last element is going to be j. What I said, check this, A of I is lesser than pivot element. Is 3 is less than 4? Yes, I increases. Is 2 is less than 4? Yes, I increases. It is 8 is lesser than 4? No, stop it. Then go to the right hand side. Is 9 is greater than 4? Left side I we are saying that lesser values. Right side j is greater than values. So is 9 is greater than 4? Yes, j decreases. 7 is greater than 4? Yes. 8 is greater than 4? Yes. J came here. Is 2 is greater than 4? No, stop. Look. I position, new I position is this and index is 3. J position is, index is 2. Is I is less than j? I is 3. Is 3 is less than 2? No, 3 is not less than 2. It will come in other part. So I have A of j and pivot. A of j is here and pivot is here. So we are going to swap it with the pivot element. So how it looks like, friend? It go like this: 2, 3, 4, 8, 7, 9. Look, this is the pivot element, new pivot element, and left side of the array is 2, 3, right side of the array is 8, 7, 9. Again, this pivot element is divided the array into two parts such a way that lesser element, left side element is lesser than pivot and right side element is greater than the pivot element. So again, we are not going to do anything with 4. 4 is already there in the sorted place. 10 is already there in the sorted place. We are not going to do anything with that. Done with? Now, let us see that in this case. This is the pivot element. Recursive call. Left recursions, right recursions. We have to do both. P. Next element is I. And last element is J. Hence, this is again J element. Because in this array we have two elements. First element is pivot. Next element is I. And last element is J. So, both are pointing to the same place. Now, we need to check. Is A of I 12 is lesser than pivot element 14? Yes. So I increases. No, I was pointing to 8. Now new I is 9. In your condition fail. 9. Do you have any other condition to perform? No, we don't have that element itself. Okay. So we are going to compare with the J. See here. Is 12 is greater than 14? No. Stop. Now I position is 9. J position is 8. Is I is less than J? No. 9 is not less than 8. 9 is not less than 8. It means what? It will come in else part. And swap A of J and pivot element. A of J and pivot element. If we swap, we are getting pivot element here. Okay. So this was the pivot element. Right. This is the pivot element. 4, and here we got the pivot element separated. Okay. Here now we have only one element left. So this is the P, this is the I, last element is J. So your position of J is lesser than I, hence it is also sorted. Right. Now we have two parts, two conditions. Here is a P, last element is I, J. Look. Is 3 is lesser than 2? No, it will stop here only. I stopped. No, J will compare to J. Is J 3 is greater than 2? Yes, J decreases. Is 2 is lesser than 2? No. 2 is not greater than 2. A of 2 not greater than 2. 2 is not greater than 2. Hence stop. Now see the I positions. I position is 1. While new J position is 0. So, it will not come in I less than J, it will come in I greater than J. Swap A of J and pivot. A of J, this and pivot. The 2 got separated. So, 2 got separated. Hence, 3 is also got sorted. 4 also got sorted. Here we have again similar way. P element, I element, J element. P, I, J. So, let us see that in we got 2, 3, 4 sorted. These all are the sorted elements, right? Thereafter, we have to do 8, 7, 9. 8, 7, 9. We have to perform the task. 10 is already sorted. 10 is and 14 is already sorted. 3, 4, 5, 6. Right. So our focus is on only these arrays remaining of P, pivot element, next element is I, last element is J. Look, is 7 is lesser than 8? A of I is lesser than pivot element? Yes, I increases. No. 9 is lesser than 8? No. Then go for the J element. Is 9 is greater than 8? Yes. So 9, J decreases. Is 7 is lesser than 7 is greater than 8? No. Stop. So I pointer is 5, J pointer is 4. So I is greater than J, hence swap between A of P and J. So it is 7, 8. 8 is a pivot element. Now 9, 7 got separated. In this case, this is the P element, next I element, and this is the J element. Hence, this got separated. This is a singular. So all elements got separated and sorted. So at last, this is our sorted elements 2, 3, 4, 7, 8, 9, 10, 12, 14 by using quicksort technique. So I hope you understand this. Let us see that program. Into the array elements, we are reading n is equal to, as per our example, n is equal to 9 elements. Into the elements one by one, we have read the element I is equal to 0 to n by scan of quick ease of functions. You pass the array name, low index 0 and high index n minus 1. Low index 0 and high index n minus 1 means 9 minus 1 is 8, because we have read n is equal to 9. So 9 minus 1 is 8. So 8 is index, and we can see that in previous examples we have index from 0 to 8. Yes, no? So Thereafter, what you are supposed to do, we are going to perform this task before printing these sorted elements. Sorted elements we are going to print at last, as we did it here. Sorted elements from 0 to last element 0, 1, 2, 3, 4, 5, 6, 7, 8. So 0 to 8, we are going to print all the elements one by one. Okay, so that is the outcome part. Right, once you are already sorted all the elements in ascending order. What you have seen here, friend, if low is less than high, if 0 is less than 8, then only you are going to do this work. And what is that? I is equal to partition. Remember that partition is a one functions, and we are passing a, low is 0 and high is 8. We are passing. So we are just holding this part. We go first to the partition functions, and what you are going to do it. Let us see that. In this, whatever the work we have done it there, we have run with the two loop, I is less than high and key values must be greater than a of I. You will remember that there we have written that while a of I less than equal to key, or we can say that pivote, whatever the name you are going to use. Key. So this is the second parameter. Look, a of I is less than equal to, or you can say that reverse case, key is greater than equal to a of I. If this is there and position of I is less than, see your position of I low plus 1. Low plus 1 is, as I said you that very first element, key element is a of low, that is a pivot element. I is low plus 1. Next element, what I said, it is I element. Last element is J element. So I must be lesser than equal to high. Till that moment you are going to perform the task, and we are increasing the values by I plus plus. While K is less than J, I said you that second condition, that while A of J is greater than key, then J minus minus. So A of J greater than key, J minus minus. Same things, I have used the symbol in reverse order by changing that variable also. Hope you can understanding in proper way. Then we have condition, two condition. If I is less than J, swap A of I and A of J, else swap A of key element and A of J. That we have done it and return J. Let us see, if you are not aware of the swap function, then we need to write at the place of swap that temp is equal to A of I. A of I is equal to A of J and A of J is equal to temp. Okay, for this swap function you can write all the codes, and if you are writing 3 lines inside this if statement, then it must be in curly braces. One line we can write directly, more than one line we have to use the curly braces. Similarly, here is swap pivot element with A of J, then we have to write temp is equal to key is equal to A of J is equal to temp. So 2 times you have swap functions. Return J. Once you are going to return friend J, that will go and sit here at the place of I. What are the values of J? It will come, it will sit in place of I. So let us see that in previous example, very first case, we have divided the array into 2 parts based on the J element. And what is the position of J friend here? Is 6. Is 6 is the index. So let us see what is the higher index here? 6 minus 1. And beginning of the index in the second array is 6 plus 1. 6 minus 1, 6 plus 1. It means for J minus 1, J plus 1. Quick function calling itself A low. Since that J positions element you have stored in I as a variable, so I minus 1. Left array. Right array, A, I plus 1. Pivot positions, that J positions plus 1 and high. Left, this is so, it is a left array and this is the right array after division. So this is called basically left recursion, this is called right recursion. So parallelly 2 recursive functions will work here. Okay, and this will happen again and again as we have discussed in the example, right? We'll do these stuffs repeatedly until or unless we are getting all the elements in ascending order. Now there is a two case here. While we are dividing the elements based on the pivot element, then array's element will be divided nearly half, nearly to half, or maybe equal in size, both the arrays. In that case, that is the best case of quicksort, when you are able to divide the array into two half based on the pivot element. That will be the best case of quicksort technique. But in quicksort, when elements are already there in ascending order or descending order, right, then it will take more time. That is the disadvantage of quicksort technique, that if element is already in sorted order, then it will take more amount of time to sort it. Okay. Then conclusion is, for random elements, quicksort is quickest technique to sort the element, fastest technique to solve the problem. But you should be careful, if elements are already in sorted order, whether ascending or descending, then it's consume more time compared to merge sort. It's consume more time compared to merge sort. So there is a we can say that difference between merge sort and quicksort. Merge sort, all the elements are divided into two parts based on the middle elements. That middle element you are going to compute based on the index, low index and high index. While in a quicksort, we are going to divide the array elements based on the pivot element. Second, merge sort, in all case, best case, average case and worst case, time complexity is n log n base 2. While in quicksort, we have a three different time complexity. T of n is theta of n log n base 2, right, in a best case. Okay. Then we can say that in average case it is a theta of 1.38 n log n base 2. Okay, in average case. In average case, time complexity is n log n base 2. Here also it is the same, n log n base 2. Here is a constant multiplicative factor is 1.38. That's it. Then worst case it is n square. Worst case, when elements are in sorted order, then it will take more amount of time to perform. So you should be aware. So I think everyone is clear with this programming part. Let us see again, there is no difference while we are talking about best case of quicksort. Best case of quicksort, when element is in random order, or time complexity of merge sort. We are getting same 2tn by 2 plus cn, tfn by 2 plus tfn by 2, time taken to perform the left side of the array, time taken to perform the right side of the arrays, and n is time taken to divide the arrays elements based on the pivot elements. Now we are going to perform this task similar way as we did it in the previous examples called merge sort. So kindly go through merge sort time complexity discussions by using backward substitutions rule, and we got that n log n base 2 as the time complexity of merge sort as well as quicksort in a best case complexity. Now what will be there in average case? Okay, so let us see that why average case complexity is different. Here again same things we are talking about. In a best case, if you have time complexity in a standard form 2tn by 2 plus cn, and since it is in standard form, of recurrence relations, we can identify A, we can identify B, and we can identify D as a 1 and B power D as 2 power 1 is 2. Hence, it is A is equal to B power D, both are 2. So, it will fall in second case, and in that case, time complexity is theta of n to the power D. N to the power D, D is 1 log n base 2. Right? So, this is the time complexity based on the master theorem. But this master theorem you cannot apply for worst case of quicksort. Okay? When you are talking about the worst case of quicksort, let us understand first why it is worst case. Say we are having 2, 4, 6, 7, 8, 9. Okay, 6 element. How many number of elements, friend? 6. 0, 1, 2, 3, 4, 5. And all of you can see that this is in ascending order. It means it will take more amount of time to compute. So, this is the pivot element, this is the I element, I position, this is the J positions. Since you all aware of quicksort algorithms now, then we can practice it that if A of I is lesser than J, then I will increase. Is A of I, A of 1, 4 is greater than 2? No. So, I will not increase. The second part we are going to compare with the J element. While A of J is greater than pivot element, then J will decrease. So, A of J 9 is greater than 2? Yes, J decreases. 8 is greater than 2? Yes, J decreases. Is 7 is greater than 2? Yes. Is 6 is greater than 2? Yes. Is 4 is greater than 2? Yes. Is 2 is greater than 2? No. So, look in these scenarios, I position, I index is not increases at all. But J decreases from last arrays to the very first positions. It means we have performed the more number of comparisons and we came to the first positions. Now what will happen in that case? Pivot element will be swapped with the pivot element. So 2 is swapped with the pivot element 2. Hence this work is completed. Rest of all the elements are in one array. Rest all the elements are in one arrays. Then again you are going to perform the task. 2 is sorted and 2 is divided the arrays into two parts. Right array, left array. And what you can see that? Do you have any elements in the left hand side? No. All the elements are there in the right hand side. Hence, if elements are there in sorted order, we are not able to divide the array into two halves. We are just decreasing the array size by 1. Size of array was 6, 1 got separated, remaining 5 is still there in the arrays, right? So, just problem size is decreased by 1. We are not able to divide the array into two parts. Let us see that this is P, I, J. What is the condition? If A of I is lesser than pivot, then I will increase. If 6 is lesser than pivot, no. So, I will not increase. Go to the other side. J. Is 9 is greater than 4? Yes. 8 is greater than 4? Yes. 7 is greater than 4? Yes. 6 is greater than 4? Yes. 4 is greater than 4? No. Stop. See here I positions. I is 2, J is 1. If I position is greater than J, in that case swapping will happen between pivot element with J element. Hence, now these 4 got separated. Remaining, these all 6, 7, 8, 9 is a part of right arrays and we need to perform the task. So again in these iterations, if these all elements was there as a part of one arrays, we are not able to divide the arrays into two parts. Just we are dividing such a way that all the elements, rest of the elements, n minus 1 element is there in the right hand side and left side we don't have any elements. So it will take more amount of time to perform, and when you are writing the recurrence relations, what will be the T of n is equal to, right, T of left side, do you have any elements? No. Right side we have T of 0, T of n minus 1, right, T of n minus 1, because array size is decreased by 1. Array size is say T of n minus 1, right, plus n, right, got the point? Hence, what about the, if n is greater than 1, if n is equal to 1, are you able to divide the array into two parts? No. So, if n is 0, right, number of element is 0, in that case also you are not able to perform the task. If number of element is 1, in that case also you are not able to divide the array into two parts. So, you can write it n is 0 or n is 1, both is okay. Alright. So, let us see that how we are going to perform this task one by one. Okay. And here even to simplify this, you can take T of n minus 1 plus n as a variable point and see how you are going to perform the task, right. So, we are getting T of n minus 1 plus n. Next time what will happen? T of n minus 1 becomes T of n minus 2, n minus 1 plus n. Next time T of n minus 3, by using the backward substitution rule we have applied it here, plus n minus 2 plus n minus 1, this is original plus n. Next time what will happen? T of n minus 4 becomes T of n minus 4, 1 less, n minus 3 plus n minus 2 plus n minus 1 plus n. When you are going it, what will happen? Say after n iterations, what will happen? T of n minus n plus, if it is n, right, then we will be getting here, see here, n minus 1 n, right, n minus 1 n, one more, n minus 1 plus 1 is one more. So, n minus n, when you are doing it, right, then we can say that this should be one more, right. Look here, here is subtracted by 4, here is subtracted by 3. So, similarly n will be getting here 1, 1 plus 2 plus 3 dot 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 dot, we have n minus 2 plus n minus 1 plus n. N minus n becomes 0, hence this time complexity is 0. What you are getting here, friend? 1 plus 2 plus 3 plus 4, hence plus n. This is the sum of n natural number, hence time complexity is sum of this n into n plus 1 divided by 2, T of n. Hence n into n plus 1 divided by 2, it is quadratic. So, we can say that T of n is equal to theta of n square. So, time complexity of quicksort worst case is theta of n square. Reason is we are not able to divide the array into two parts, we are decreasing the array size by 1. If we will do the pictorial representations, right, how it looks like, we have say problem size is of T of n. Left side, are you having any arrays? No. We are having in the right side T of n minus 1. Again T of n minus 2. Left side you don't have any elements. We are going in the right hand side only. So what will happen? This is goes keep on in right side of the arrays. In that case, number of comparisons will start from here, right? We will compare here, then right hand side, right hand side, right hand side, right hand side. So it is a right skewed trees. Basically, when you are applying worst case, it will be right skewed trees. Hence, it will consume more time to perform the task. Okay. So let us conclude it here. Is that quicksort technique, merge sort technique is based on the divide and conquer strategy. Quicksort technique is called quickest technique if elements are in random in order and time consumed to perform the task is n log n base 2, while in elements are given in sorted order, then time taken to sort the element will take more amount of time, that is n square. Okay. And in merge sort, in all cases, best case, average case and worst case, you will be having time complexity T of n is equal to n log n base 2 only. So best case, average case, worst case of merge sort is n log n base 2, while in quick sort, best case, average case fall in n log n base 2, worst case is n square.